Welcome to All Space Considered, everybody. We are, and as you can hear, we are live from the Leonard Nimoy Event Horizon Theater at Griffith Observatory tonight. This is the first time in 3 years. So yes, thank you all for showing up tonight. We have an audience of about 10,000 here tonight. No, but honestly, we didn't advertise that we were back in the theater so much because we're a little rusty. So those of you watching at home, bear with us. We're going to do the best we can. It could be exciting. We could, well, we're not used to this. I'm used to being able to see what's actually going on the stream and whether we're picture-in-picture. I mean, so we're going to do our best, but it's going to be a good show. We have a lot of fun. So as you can see, the third Thursday of every month now. So that might have thrown some people off. We'd probably have people showing up on the first Friday still. But today is indeed Thursday, March 16th, 2023. And it is our, like I said, our first live All Space Considered here at Griffith Observatory in more than 3 years. Our last one was in 2020, March, whatever the first Friday in March was. And we had debated whether we should have the show, and we decided to go forward with it, and we did. But this show, as always, is brought to you by the City of Los Angeles and the Department of Recreation and Parks, and Griffith Observatory, of course. And as always, we like to thank Griffith Observatory Foundation, our nonprofit partner. They help us with so much of what we do. We thank all the members and all the donors. But with me tonight, I'm Dr. David Reitzel, and with me tonight is Chris Butler. And Katie Flynn is here as well tonight. And also Jared Head is on the stage tonight, everybody.
Howdy, howdy.
That's right. So we're going to have some fun talking about, well, let's take a look at what we're going to be doing. First of all, I'm going to open up the evening's program with a Women's History Month topic. And we're going to talk about Caroline Herschel. And then we're going to turn to our comets, meteorites, meteors, meteoroids, asteroids section. And we're going to talk all about craters, impacts, triple asteroids. Well, it wasn't a triple asteroid, really. I guess it was a triple meteorite that was found. A triple asteroid would be cool. The DART mission, a little bit on that. And then we're going to do pretty pictures, solar system weather with Katie. And also, she's going to do the sky report for us tonight. And we, believe it or not, we brought back the drought report because there's good news, as you know. We're pretty wet here in California. And then, well, Chris is also, by the way, I want to point out, he has sort of a historic approach to the impacts and meteorites in the first half. And message for you, Chris.
Uh-oh.
And so he's going to be talking about that. And then in the second half, we'll have Out to Launch with Jared. He'll talk about all the spacecraft that are doing things. And then we have a Ryugu report, which is going to be really interesting. But it is another video. Our museum guide, Haley, unfortunately, she was exposed to somebody that was sick and didn't want to expose any of us. She's feeling fine, and I hope you're fine out there, Haley. But she decided to record her video for us tonight. So we're still a little bit hybrid, but it'll be interesting. And then we're going to talk, well, we have craters there, although I moved those earlier. I messed up on Katie. Like I said, first one back in the theater in a long time. And then the space news, I doubt we're going to get to it. In fact, it's just not going to be there at all because alas, we've got a long enough show. So
we do.
Moving on. Women's History Month. Indeed, it is Women's History Month. And keep an eye out for a tweet about all the wonderful women in the top of this image up here. We're gonna queue up some tweets after the show and send those out in the upcoming weeks. So you'll be able to hear about some wonderful women that did some science and astronomy. But tonight, I want to talk about Caroline Herschel. And believe it or not, today is her birthday. March 16th, she was born in 1750. So in Hanover, it was actually the Holy Roman Empire at the time, but of course today it's in Germany. And she was an amazing individual. She originally started out sort of a helper for an astronomer, but quickly started observing on her own and started discovering everything from comets. She was the first woman to discover a comet. She discovered many nebulae, which, by the way, that both includes what we call a nebula today and also galaxies. Back in the day, a galaxy was just a nebula. It was a nebulous-looking thing. And she found dozens of these. And right here's her comet she found. Ryugu was also another person that discovered this comet that is credited to both of them. But this is a comet she discovered. It's a periodic comet. It comes back over and over again. These are many of the objects that she's credited as discovering, which is pretty great. And also notice that NGC in front of that. That stands for New Galactic Catalog, or New General Catalog, rather. And that catalog is used today. We give these objects these names, NGC with a number, a catalog number. She was the person that published the precursor to this catalog. She went in and put in corrections to it, found a bunch of corrections for stars. Her published catalog of nebulae eventually became the New General Catalog. So without her, we wouldn't have the NGC.
That's amazing.
Which is amazing.
I had no idea.
Yeah, well, maybe we'd have it, but it wouldn't be the one we have today.
Right.
This is known as Caroline's Rose. It's one of the clusters there. And this is the Caroline's Cluster. So she has clusters named after her up in the sky, common names. She has an asteroid that's named after her. This is Lucretia. That was her middle name. And this is a model of what it looks like. We don't have any up-close images of it, but we do, based upon the brightness curve and how it gets brighter and fainter and brighter and fainter, this is what it probably looks like, we think. She has a crater named after her on the moon. So you can see in there, that's one of the Imbrium, Chris, do you know?
Yep, Mare Imbrium.
Mare Imbrium.
Should.
And in the western part of it, we can zoom in here. Zooming in, you see the crater that's kind of in the center left of the image there. It's along that vertical line.
Oh, yeah.
And we zoom in a little bit more. It is in the lower right, labeled C. Herschel. That is her crater on the moon. So she's been honored quite a lot. And she was awarded the Royal Astronomical Society Gold Medal.
Yeah.
There was not another woman awarded this until Vera Rubin was. I forget the year.
Wow, that's
but it
a
was
long,
in like the 90s or 80s or 90s. So completely crazy. Now, look at the telescope on the right-hand side on that gold medal. This is not actually hers. This is another astronomer's. I couldn't find a copy of hers.
Right.
But do you see that telescope there? That was the telescope she helped create and design. So she was responsible for the helping and the creation of this. I actually did get to see a piece of this when I was in the Griffith Observatory. They still have a little chunk of it there that you can look at, which is pretty neat. But here's another drawing of it, an etching. And on the right-hand side, some of the instruments she used. That little telescope was one that she was using. She used to scan the skies looking for it. Now, you might wonder, how did this woman do all these amazing things back in the late 1700s, early 1800s? Well, she's the sister of William Herschel, who discovered Uranus. He discovered, I believe, discovered infrared radiation, I read, although I never did check whether that's true. But he published catalogs of stars, and without his sister, we're not sure if he would have been quite as successful. He still would have been. He found Uranus on his own. She was off on another project at the time or doing something else. But she was there assisting him night after night. She would help calculate the positions of objects in the sky. So she was doing extremely complex mathematics. It's not easy on a spherical sky to calculate where things are. No. So it is because of her and her care and the effort she put into it that these catalogs were so well regarded. So the two of them made a wonderful pair to do research. Later, she was doing research on her own. He passed away much earlier, and she continued to do her research, continued to make these discoveries. So today, for Women's History Month, Caroline Herschel, Caroline Herschel, is somebody we should remember and think about. And of course, when you pass the Astronomer's Monument and you look up at her brother, who's out there on it, think about how he had a sister who, in my opinion, is maybe not quite as important for astronomy, but had she have not been his sister, she should have been another pillar of early astronomy observations. She was famous enough that there were cartoons drawn about her discovering comets that were in popular magazines and things.
That's so cool. I mean, she's living in a world, the Jane Austen world.
Yes.
She's living in that, and her idea of a thing to do, I'm going to go out and discover comets.
Yeah. Well, there's more to the story. A fascinating woman. She did fight through adversity. Her parents did not want to educate her. They thought it would be best if she did housework and was there. And it was actually her brothers that said, no, they had to convince their parents, no, let her come with us. And they let her pursue education. Although at the same time, she had to keep house. She had to help raise the kids. So she faced a lot of adversity. And I can think, gee, a lot of men I know of wouldn't be able to make their discoveries if they were also doing housework and taking care of the kids and educating. By the way, she made a very close relationship with her nephew.
This is William's son, John.
Yeah, her son John, who went on to develop photographic techniques and also published more catalogs and things with her. So he became very interested in astronomy because of her and his close relationship. John Herschel was his name. So Carolyn Herschel, quite amazing. Moving on to the next topic. This is the first astronomy conference that I, well, didn't really attend. I was working it. Had just gotten out of undergraduate. It was 1991. I was down in Flagstaff, Arizona for a couple of months. It was a class through USC where I graduated. And this is the book that came out of it, which is one of the reasons I was kind of excited about this topic that we're pursuing tonight at All Space Considered, which deals with comets, meteors, asteroids, meteorites too, and meteors.
Sure.
So we're going to start out with a picture of our museum guide, Stephen, here. And he's holding up the meteorite. So yeah, Bill. Yeah. We're going to need the meteorite. We're going to pass this around, but Bill's going to say a couple of words, although there's a bigger part of this, anyway, to introduce what this is,
Okay.
Say a couple of words, and then there's more later.
Yeah, Alex Carr is going to, one of our best museum guides, is going to help me to facilitate this. We're going to pass around our 8-pound iron nickel Diablo Canyon. I'm sorry, yes, meteorite, which is always at the edge of Space Desk, and anytime you're here, you can pick it up and hold it. And I just want to say one thing about it in particular, which is that it's very, very old. Dr. Reitzel will talk about this. We're talking about 4.5 billion, trying to drop it there, billion years old. 4.5 billion years old. So as this comes around and you get to hold it in your hand, just realize this is a little joke I like to tell when I'm doing this talk out here in Edge of Space area. This is the oldest thing you have ever touched in your life. And it is the oldest thing you will ever touch again, even if you shake hands with me. That's my joke, my stock joke.
Exactly.
So we'll try to make sure that I'm going to continue to help Alex and facilitate passing it around. We want everybody to get a chance because it's really an amazing thing to touch something from space, 4.55 billion years old, give or take 700 million years.
Yeah.
That's the
So
margin of error.
now, folks at home, we probably have a larger audience at home watching than we do here. That rock, Stephen's holding that up, but it's only because of his immense strength that he's able to hold up that 8 pounds like that. No, actually, it's dense and it's very heavy. And if you're ever at Griffith Observatory or another science institution that has a meteorite to hold, it's shockingly heavy.
Yeah.
And then you'll know when you're picking up stuff out in the field, you'll know when you've picked up an iron meteorite.
Yeah, we're not throwing it around the room for that reason.
Yeah.
It's not something you want to catch.
So, now, stay tuned. We're going to tell you what a meteorite is eventually, but for those of you in the audience, just remember what it's like to touch it there. So first of all, well, there's a meteor. This is a picture of a meteor or a shooting star going through the sky, as you can see. This is a picture of a meteor shower. Hello.
That's what they sound
Somebody's
like.
phone rang, which I'm stunned we had a phone ring in here.
A phone in the shower?
How did you get a signal?
How did you get a signal? Anyway. But the shower, this was a time exposure. So the shutter was left open for a while, and meteors didn't all happen at once, but over a period of maybe an hour or something like that, you caught many, many meteors. And they all appear to kind of be coming from the same direction. So that's something meteor showers do. And they're actually caused by comets, and there's a couple of them that are caused by asteroids as well. Now, how does that happen? Well, as a comet travels through its orbit, it leaves debris behind. And as the Earth's orbit crosses that path the comet was in, we end up seeing meteors. Now, here's a meteor from the International Space Station. So looking down from above, you can see, yes, indeed, that's created in our atmosphere. It's not up above, it's not glowing on its own, it's the glowing atmosphere making that happen. And you can see here, this would be a large meteor coming in, what's known as a bolide, and it would come in, the atmosphere heats it up, it explodes, and particles can shower down and land on the ground. So the meteor is the glowing light in the sky you see. The meteorite is the chunk that makes it to the ground, if anything does. Most meteors are caused by little tiny grains of sand, and they burn up in the atmosphere, so you never get anything on the ground. But if the object is large enough, it'll come down and leave meteorites on the ground. Now, interesting, when it's floating out in space, but if it's destined to become a meteor, if it's destined to run into the Earth, it's what's known as a meteoroid. So kind of a fun little term. So here is a video that I think, just nabbed right off the internet. So anyway, thank you whoever made this. And you can see the comet leaving behind the debris, and then the Earth moving through. And it's the intersection of the motion of the particles that came off the comet and the Earth's motion that create that radiance. So you can see when you stare off in the direction, that's the combination of the particles' movement and the Earth's movement, they tend to all come from the same direction. It's a little bit like driving in a car. And during a rainstorm, it looks like the rain is coming from in front of you, when in reality you know it's falling from up above. But as you drive, it really looks like the rain is coming at you. So it's the same effect. And you can see if you were to put it up against sort of a sky chart, this is what it would roughly look like. Now, the particles aren't all perfectly coming from the same direction. There will be a little bit of deviation here and there. But if you see a meteor that shoots across all of these, you know it's not related to the meteor shower. It's just a random meteor. There's also particles coming from random directions as well. By the way, if you want to go see a meteor shower, what you want to do is get to a dark site, and this is what we're dealing with today. This is the United States. This is the sky brightness. The little pins that are put in there are showing dark locations. Joshua Tree is in the lower right there. It's blue. It's no longer dark black. So even though you think, oh, we're getting a great view of the sky, it's really great here. No, it's blue. You need to go out into the deeper into the Mojave to do that, or into Nevada. So, and the poor folks on the east, it's really nowhere you can go.
Yeah.
It's nowhere at all. So the moon gets in the way of meteor showers. So you have to look for a shower where maybe there's not a full moon. Don't get all excited and plan a trip for, travel thousands of miles to go see a meteor shower if there's going to be a full moon. You won't see many. And here is our meteor shower calendar for 2023. We finally have updated it. We've updated the screen throughout the building as well. But as you can see, there are a lot of comets and a lot of objects that have created meteor showers, and they occur throughout the whole year. One of my favorites is the Perseids, of course, because it occurs in the summer. You can go camping. The weather's nice. But actually the Geminids, which occur in December, it's cold, but they're a great shower. The Lyrids can be another really good one. But they can get good, they can get bad, depending on the density of the particles in that stream. And that's something we can measure. The closer the comet is to where we're crossing the stream, generally the more particles there are to run into. So pay attention to the news, and when you hear an astronomer predict there might be a storm, a meteor storm, well, you get out and look and you give it a shot. Sometimes it happens, sometimes it doesn't. This is one of those fun things that you go out and you experience it, and you hope you get to see the best. I've never seen a meteor storm.
No storms, not for me, no. Showers, yes. Storms, no.
Yeah. Well, I'm going to talk a little bit about, here's the way to do it. Bring a deck chair like that, kick back, get some, a hot beverage of some sort, coffee, cocoa, whatever you like, tea, and lean back and enjoy the show is really the way to do it.
Hello, everyone. Daniel here. Unfortunately, I'm stuck in the middle of this redwood forest, so I can't be over at Griffith Observatory for our first time back since the start of the pandemic. But I hope you all enjoy the rest of the show, because I can't wait to see you all when I get back. So, bye, everyone.
So that was Daniel, our museum guide Daniel, who's up in the redwoods, Santa Cruz campus. Actually, that's where I got my PhD. He put together this little story for us here. So let's take a look here. Yeah.
That's what I'd say.
That's what I would say too.
I saw it cross Perseus. Oh.
Yeah. It's also what's known as a fireball. This one was predicted. They knew to go look for it. This was one we saw before it came in and impacted. It was only a meter or two across, so the size of, I don't know, a VW bug or something, maybe a little smaller. They saw it come in, and it was a bolide burst. It was off the coast of France there. And you can see some photographs of it. Again, people were ready. They were told to go wait for it. After it happened, they got together in lines, walked the fields, and looked for meteorites. You walk up and down, and you pick them up. And indeed, they found some. That's a common chondrite, which is a stony type of meteorite. Probably has some metal in it. Generally, a magnet will stick to meteorites. There are some that are the rare carbonaceous ones that look like just a plain old rock. They'll have a fusion crust on them, but when you break them up, they look like a rock, and they don't even have much metal in them. And those are common, but hard to find because they look like rocks.
They look like all the others.
People pick them up with magnets mostly. You can see here more pieces of that same that same meteorite that came. There was another one that was that went right through the boot of Italy, kind of right through the center of it there, which is why I showed Italy. And here's a picture of it. And here are the chunks that came in. Now, all these happened right within the course of, this one happened on Valentine's Day. These were all right in a row, which is why we put them together as the triple meteorites. You can see more chunks from that one. They can be very, very small. Sometimes they crumble. If they're small pieces, they could crumble together and kind of fall apart. So you have to watch for that. Now, the final one was another one off in Texas. I think this one might have been predicted as well. I forget. So we're getting better at finding them and predicting them.
Right.
But they did find chunks of it. So it looks like another common chondrite again. So all three right in a row, kind of crazy. Now, the Texas one is fun because this was on the date, 10 years to the day of this one here. Do you recognize
Oh,
this one?
yeah. What a day that
Yeah,
was.
what is this?
Well, this is Chelyabinsk in Russia. This was an incredible impact. Some of the footage from this was better than any I'd seen for a big event like this before. And one of the reasons I want to thank all the people who have automobile insurance in Russia,
Yeah.
because everyone has a dash cam to document your accident. Everybody. So all the
Yeah.
people driving around got great footage of this.
They did. And we have a video we're going to show that first shows some dash cam video, and we've got some Russian music too, which is great. And then you'll see the impact. You'll hear the boom, and then finally you'll see a building that was actually knocked down due to the shock wave. So this was an airburst.
Yeah, it didn't hit the ground, but it sure shook the sky.
Yeah, there were chunks.
Oh, that's true.
Some pieces fell to the
crater.
ground, but the main body of it did not. So this was just somebody driving along, although I'm not hearing the music. It was
И вот туда дальше.
here's
Ой. Охренеть.
now I hope he's not swearing.
I'm glad we can't translate that.
Слышишь?
Yeah, and here's the building that was, you can see bricks.
Yeah.
It was a warehouse
Wow.
of some sort of a factory. Came down. So, anyway, it was the old footage we had that had the Russian techno in it. I forgot.
Yeah, they broke
So,
a
but-
lot of windows, you know?
Broke windows.
Wow.
So, hint, if you ever see something like that in the sky, don't stand at the window. The sound, the shockwave travels slower, of course, than the light does. And it can be 5-8 minutes before that shockwave hits you, even longer. It depends on how high in the atmosphere it goes off. So, that's what happened. I forget the exact delay, but it was minutes.
Well, yeah, it depends how far away you are from it, too. If
Yeah,
you're standing farther back,
exactly.
it'd be a longer delay.
Yeah, so, but folks stood at a window, said, wow, what's that thing? And then boom, the glass shattered and they got cut. So a lot of people were injured from flying glass. Nobody died from the direct effects. Somebody might have had a heart attack or something, I don't know, but
Yeah.
nobody was killed by flying
Actually, yes, I
glass.
think someone did.
So,
But no one directly.
yeah. So now this is back to our meteorite that we passed around, and I think it made it all the way through our audience here. These are some of the bigger pieces that are right out on our edge of space. You can go out and see. So very, very heavy meteorites. The chunk you had was a small piece of it. That one also, we think probably most of it was vaporized when it impacted, forming this crater. This is Barringer Crater, a meteor crater down in Arizona. It's east of Flagstaff. You can travel there. Now, like Bill likes to say, it's amazing that it came this close to hitting that visitor center there. They got really lucky. But do visit it. I got to go visit it, hike down to the bottom of it. I'm not sure they allow everybody to do that, but it's super cool. By the way, if you slice open one of a metal meteorite like this, it shows these Wittgenstein figures. And what these are is if you cool a metal super, super, super slowly, we're talking over, I forget the exact amount of time, but you can't do it in a lab on Earth. It'll form crystals, and you're seeing these crystal structures within the meteorite. You have to cut it and then polish it very carefully and then etch it with some acid to bring these out. So super, super cool stuff. It's really amazing. And these have been falling to Earth for quite a while.
Oh, yes,
in
indeed.
fact, since the beginning, they probably were more common. And Chris, you put together a little presentation that talks about some of the
Yeah, absolutely. One of the things I want to make sure everybody understands here, because we talk about a lot of these events that are happening these days, And it makes it sound like it's a modern problem. This is something that's just happening in our time. We're much more aware of it, of course, than people ever were in the past. But I want to look at human history here a little bit. Was this a part of history, even ancient history and so forth? It is a little hard to picture like Abraham Lincoln out delivering the Gettysburg Address and kaboom behind him, right? We just, no, it's like a future-y thing happening back then with the assumption that these people would have absolutely no clue what was going on. You know, here you've got a guy with a roundhouse living in the Bronze Age or something. Did these things happen? Well, one thing I want to make a point of, the period I'm looking at is what we'll call history. That's the green band is what we call ancient history, and the blue is recent history. Most scholars define history as beginning when complex writing systems began about 3000 BCE, as we say these days, before the Common Era. And after that point, you can write down what happens in a complicated tale. Before that, though, you might be drawing pictures of things or whatever, or just passing them down verbally, right? But history really begins back in the green area. I want to point out that the ancient Egyptians, this is important in a moment, are at the beginning of recorded history, ancient history. The monument of Stonehenge would be another example, something happening around about that time, ballpark of 5,000 years ago. The Greeks are kind of in the middle of ancient history and the Romans kind of at the end. I do note something on the ancient history section there. You see the bar fading in for Iron Age. Now, certain kinds of metals are harder to work than other metals, and iron is incredibly strong, but it's hard to work with. Somewhere around 1200 BCE is when cultures started working more with iron, ushering in what we call the Iron Age. Before that was the Bronze Age. Bronze was a bit easier to work with. Notice that the Egyptians and the Pyramid of Khufu there and all that, they are in the Bronze Age, when we wouldn't expect a lot of metal working. So this is the time period we're looking at here. One thing for sure to notice, this is a map showing the world and showing the density of human beings around the world. We don't have lots of tales of these Chelyabinsk kinds of things or what have you happening all over the world. One of the reasons why is there, in the past, were much, much fewer people on the world. They were scattered. It was a much thinner population. And when we get to talking about the threats from asteroids and so forth today, that's one of the reasons it is a big threat, is because we're covering the surface of the Earth now, right? There's a 2/3 chance it'll hit in water, but if it hits land, right now, there's a McDonald's on that land, right? So that's a big deal.
Well, if it's big enough and hits water, you get a tsunami. So
That's
everybody
true.
on the coast is in trouble.
And of course, you can have climate damage from these things, a la something like the order of what would have killed the dinosaurs off. Of course, it doesn't matter where one of those hits, but even for the small things, it would be easy for people not only to be affected by it, but just even to see it. In the past, it'd be easy to be a long way from where one of these hit. We've mentioned Chelyabinsk and things like that, but this is not alone by any means. So you were scrolling through a list. Here we have one in Peru, just recently, 2007, dug a crater out. People saw it. Again, there were people in this remote part of Peru. We have a display outside here on the edge of space of the Allende meteorites from a 1969 fall in Mexico. Again, that's very recent. This is the big previous one in 1908 in Siberia, Tunguska, Russia. We have a very big airburst that flattened part of a forest. It's been cleared out by people in recent years. All the trees weren't vaporized there. They were actually all laying down on the ground. A forest was flattened by this. And this was a big enough one, it doesn't matter where you were, because this happened in Siberia and they faintly heard it in London. The sound wave traveled that far. That's an example of a big one, and nobody's forgotten about Tunguska. But there are others. This picture here is one I'd never heard of in my life out in Saudi Arabia. This is from a researcher, Gene Shoemaker, famous planetary geologist, was researching smaller impact craters on the Earth This one looks to be about from 1700 of the Common Era, 1700 AD. So pirates in the Caribbean, colonists in America, and this thing hitting the sand out there in the middle of Saudi Arabia. It was happening, but was anybody even there to hear it or see it? Maybe not in the middle of the Saudi Arabian desert. Possibly not. Here's a story that's just too good. This is not an actual photograph of the event. But as an artist at the observatory, I was required to produce an illustration. This is Phrygia, which is an area of Anatolia, modern-day Turkey. Apparently, the Roman army and the Pontic army from that area were squaring off and preparing in 74 BCE for a battle. When, believe it or not, something fell out of the sky, a blazing, fiery object, and landed between the two armies. Boom, and dug out a crater. The two armies then left the field and decided not to fight that day. I mean, these were superstitious people as it was, right? They're studying how a chicken walks to figure out your fortune. 3 or 4 foot across a rock blowing a crater in front of you. It probably got their attention, right?
Yeah.
I'm assuming. Here's an interesting thing. Remember I told you that the ancient Egyptians were, before there was a lot of iron working, a lot of bronze, and gold and the softer metals, they were experts at that. But not much in the way of iron working. However, Tutankhamun, your favorite pharaoh, was buried with a dagger that is strongly iron and nickel in proportions which happen to be identical to many nickel-iron meteorites. And there is the thought that the Egyptians would have an easy time finding meteorites because it's not falling into a swamp or a jungle, right? It's sitting out there on the sand or the dirt. They could find them. To this day, people go to deserts to look for meteorites. We think this may be an early example of ironworking from an extraterrestrial source. Maybe it helped inspire people to work with iron more. It's still kind of a mystery. There are lots of small impact craters all over the Earth. This stuff has happened all through history, many of them forgotten. One of the things you need to remember is that people were illiterate. Very few people could write this down or make a permanent record of the event, and even 100 years is 4 generations. The story of having seen something like this happen would fade away if people didn't have a way to write it down. Here's an example in Australia. This is another one where we don't have any actual records of it having happened. And here is one in Egypt, another one, an older one in that part of the world, 3000 BCE, well before Tutankhamun's time. And here's one in the middle of Poland. These would just look like a little fishing hole, right, to anybody, unless you knew the story and someone had told you what happened. We already mentioned Barringer Crater out there in Arizona. Note, this is not historic times. It's not ancient history. It's prehistory, and it's pre the arrival of human beings in the Western Hemisphere, we think. We think. Yeah. Hey, when I was a kid, I actually got to go to a dig that I think it was Richard Leakey was doing out here, and I was opining to him. I was sure Neanderthals had gotten to North America. I was like 8, okay? Well, that kid who's going to show up at a thing. I've always been on board with the humans have been here longer than we thought at school. I hope it's true. We're finding some older evidence. Yeah. So maybe.
It keeps getting pushed back further and further.
It does, but maybe not as far, but we'll see. But if somebody, it'd be funny if the first guy came over and it was, you know where I'm going with this, right? 50,000 years ago, he reaches the vicinity of Winslow, Arizona, says, I like it here. Pow! I don't know, it's just a thought. The main point is that even if we don't have a lot of written records or stories that have been handed down, the Earth itself provides lots of evidence. This isn't a modern problem. This is something that's been a part of human history and the human experience on Earth all along.
Yeah, absolutely. Now, if you want to study craters and you want to get a good picture of what's been happening, the Earth is not a good place to look, actually. Erosion takes care of it. Anywhere that water can flow, there's...
Especially the smaller ones.
Plate tectonics is recycling our crust. The crust is being moved underneath. And so anyway, the Earth gets resurfaced. What doesn't get resurfaced, well, by and large, is the moon. Parts of it did get resurfaced, clearly. The Mare were recovered, resurfaced. But a lot of the moon has ancient terrain. that you can go back and look at the craters. The problem is finding them, actually, because they're on top of each other. Well, the Chang'e orbiter, the Chinese orbiter that was sent there, had a lander too, a rover, but they were able to go in and take their high-resolution photographs and find craters all over the place. They found so many more craters than were found before. And it was because they used machine learning. They were able to go in and train sort of an AI system to go in and recognize what a crater would look like. They were able to verify them and say, yeah, these are real craters. These ones are false craters. This is true. This isn't true. You can see sort of the distribution of size versus how common they are here. And of course, I'm not able to see that in detail, but these are just the different studies that have found them. But there are some really, really big craters. Now, why is it that this new study, which is the blue line up there, is finding so many more of these small diameter ones? It's higher up on the graph. Well, it's because they machine learned it. They were able to go in and find those small ones that were sort of buried in the noise. They were hard to discover. So this is the most comprehensive study of craters that have ever been done. Now, on top of it, they were able to go in and estimate the ages of these craters as well. So by using how weathered the crater looked, how disturbed the rim of the crater was, things like that, you can go in and estimate the ages of them. And it turns out that the rate of craters has changed a little bit. You'd think in the past there'd be more stuff for us to run into. Well, watch this video and also listen. They've made a little noise, a bell noise sort of, every time an impact happens. And they start with the moon. It's a very dark music too, so it starts our theme going dark tonight. But listen to it. The first 100 million, 200 million years or whatever, nothing happens. But then they start mapping these impacts they found. And just listen and see if you notice anything.
Oh, that is spooky.
Yeah. All right, 2, 1. All right, let the fun begin here. Any second now. Here we go. Okay. Did anybody notice anything?
It sounded like it picked up.
Yeah, did
sped
you
up.
notice that a little bit? Around 250 million years ago, there were more of them. Out of the blue, suddenly more show up. That's a real effect. Now, I'd understand if it were a billion years ago. You say, well, you didn't pick up all of them. They got buried. But to suddenly have it go from a lower amount hitting 300 million years ago to then 240 million years ago, the rate of impacts is higher. We don't know why. Did something pass the solar system and started tossing comets in towards us? Was there a collision 250 million years ago in the asteroid belt that sent in chunks, like a major collision? I don't know, but something went on, and it's interesting data. So it's something to keep an eye on. You can find websites like this one. This is NASA's page that talks about meteors and impacts and predictions for these asteroids. I went into here and I started to look at, have we found these things yet? Because if they're hitting us, we need to go look for the big ones. If one comes in that's, a kilometer across, that's a city killer. If one comes in that's, 50 kilometers, 100 kilometers across, well, that's a civilization killer. We don't want to have that happen. So Congress put out, like a decade ago or more, a call to discover all of the sort of city killer sized ones. We haven't found them. They didn't succeed. NASA didn't meet that goal. Came close. We found, we think something like 95% of the really big ones. But it still leaves 5%.
Yeah, the 5%, let's get to that.
Doesn't make you very, very happy. So you look here, going across the bottom is discovery date, and the vertical is the number discovered. So these are near-Earth asteroids. These are asteroids that could run into us. Notice we're still finding lots and lots of them. The discovery rate has not died down. That says there are a lot of them out there to find. Here are the near asteroid discoveries by survey, and as of 2023. So indeed you can see here and go, okay, well, it looks like it's dying down. Well, maybe we just start looking in the right directions, because here are the smaller, what size is this? This is less than 140 meters. So these are the smaller ones, and indeed maybe the discovery was fast and maybe it's plateaued a little bit. But you can see surveys are still finding lots of near-Earth asteroids.
140 meters is the size of this building. Just
Yeah.
I mean, that's pretty big.
It's pretty big. We're still finding things. Well, that was the smaller ones. These are the bigger ones. But down at the end there, you look, 2020, we're still finding ones that are bigger than a kilometer. It's not like we have found them all. So there are still ones out there to be discovered. Now, here's the one that really tells the story. The red ones are bigger than a kilometer. The blue ones are all of them. The orange are smaller than 100, or bigger than 140 meters. Sorry. 140 meters up to a kilometer are the orange ones. Notice the orange ones are still going up. That says we haven't found them all. Whereas the red ones have plateaued a little bit. We're seeing a few each year we're finding, which isn't a lot. But the orange ones, the fact that that slope hasn't leveled off, hasn't turned over and gone even, or a lot less high, that's not good news for how many are out there. That means there's still a lot of asteroids out there. So, discoveries so far, the sizes there, estimated diameter, this is just the totals that are near-Earth asteroids out there. So there are quite a few really large ones out there that could kill us. It would be bad news. So now, after depressing you all like that,
I was going to say, I'm going to be sleeping very well tonight.
really well. Everybody, don't worry about a thing, of course. So anyway, I asked our
the astronomers will stay up instead.
Exactly. I asked our museum guide, Sarah Vincent, to look into whether folks are paying attention to this at all. She dug back a little bit further into history, didn't interfere with anything Chris has done here. But let's take a look at what Sarah put together. She couldn't be here tonight either, so she put together a little video of, hopefully it's a little more fun than the doom and destruction.
Hi, everybody. Okay, have any of you ever wished upon a shooting star? Jiminy crickets, that's a lot of you.
Oh, Sarah.
All right. Shooting stars have been a part of our cultural awareness for probably ever. We go back a couple centuries to 200 CE. There's a story that's probably apocryphal that has Ptolemy saying that shooting stars are stars dislodged from the celestial spheres by gods peeking in on us. Who knows? Anyway, let's fast forward to the current era. It's just a couple centuries. Let's zoom to now. Writers are using the lens of science fiction to examine how cultures might have first interacted with and explained meteorites. Maybe they called it fire rain?
Yeah, I'm a huge fan of fireworks.
Does anybody remember Stargate?
No.
Yeah.
Other uses of asteroids and meteorites in pop culture? Dunking on bunk? That's what I'm calling this. All right. All of this means that humans have definitely been aware of the existence of and the possible threat posed by asteroids since at least 1979. It's documented. And if there's anything to be scared of, Hollywood has you covered. This is a tiny clip from my favorite disaster film, 1998's Armageddon. And yes, I will die on this hill.
It's what we call a global killer.
Global killer.
The end of mankind.
What?
Doesn't matter where it hits. Nothing would survive, not even bacteria.
God.
Well,
I don't know.
All right,
Yeah.
if that has you scared, it's okay. Because Hollywood also offers us some solutions.
You want to ride an asteroid through Earth?
Yes.
Can you recommend a way to counter the effect?
Simple.
change the gravitational constant of the universe.
All right, we may not be able to change the gravitational constant of the universe, but we are not without a backup plan. DART. Double asteroid redirection test. You've heard a lot about it tonight. You're going to hear more, I promise. All kidding aside, these Hollywood blockbusters, they employ science advisors. So I've got a montage of impact clips, and I want you to see if you notice anything weird.
Uh-oh. Uh-oh. Yeah, that's not good either.
They look really similar, don't they? Despite there being 20 years difference between Armageddon, Deep Impact, and Don't Look Up. It's because it's our best guess. We know what impacts look like, we know how they happen, and if a big chunk of space rock is coming at us and it's big enough to kill the Earth, well, kill life on Earth, whatever, the atmosphere isn't going to matter much. And neither are the oceans. Actually, the ocean is shallower than the atmosphere, so that's not a help. It's basically rock on rock. And that's what it'll look like, rendered in the day's best VFX. Okay, we've also got the internet. Ooh, it's so helpful for taking a read of whether or not people are terrified of asteroids disproportionately. And judging by these, probably not. I think we're okay. Just for fun, I'm going to leave you with probably peak internet for 2011. And it is cat Pop-Tart meteorite leaving trail of rainbow through space. There's no audio. You're welcome. That will be stuck in your head.
That's the most cheerful thing we're going to see.
Back to everybody.
And that is. Yeah, that is definitely the most cheerful thing we're going to have all night, although the section wasn't as uplifting as I remembered. But we've turned a dark corner here. So planetary defense. What do we do about these things? Can we defend against them? Do we have a plan? Well, of course, there was the DART mission that happened. And, you know, you'll hear about that in a minute from Jared. Actually, you'll hear about it at the second half. Somehow I think that's been moved in the second half, hasn't it?
Yeah. It's going to be fun, though. It's big boom.
Yeah. I thought we had a preview, but anyway. Jared gave us no previews.
Yeah. Just some big booms.
He's just last. So you have to wait for him.
Just
okay, well, that's why I was confused. But anyway, changing topics just a little bit. In 2024, there is another eclipse that crosses the whole USA. So it is, it's going to be a lot of fun. You should have made your plans already if you plan on going and seeing it, but you might be able to find a cheap motel somewhere or go off. Or if you join Griffith Observatory Foundation, you can get notified about a trip our foundation is taking. And I actually get to lead the crew that's going to Texas. So if you want to come see an eclipse with me, join our foundation. You'll get notified about this happening. Our very own observatory director, Dr. Krupp, is leading a group that's going to Mexico. So if you have a little bit more money, a little bit more time on your hands, you can go to Mexico with our director, and that would be amazing too. But we're going to have fun in Dallas. We go to Dallas first, and then we're going to go outside of Dallas, where it's out in the fields, out in the ranches, and observe the eclipse. It's going to be a lot of fun, and do some sky observing too. We're going to bring a telescope with us. And down here in the front, if you're interested in joining our mailing list and getting information about our foundation or joining our foundation, our very own Ella Ritz is down here, and she can, if you're interested, she'll have more information about that during our break. So now, this is a newsletter I got from a professor in Columbia. Ignacio's his name. And terrific guy, but if you wish to join this newsletter and get it, go ahead and Google Planetary Defense Newsletter. You can sign up for it, and it has all sorts of interesting information about what are our plans, how are we going to defend, how bad would it be if something came and ran into the Earth and hit us. Now, keep in mind, all these impacts are very, very rare. We don't expect one to happen tomorrow. A big one that could really damage us might happen every 50,000 years, and it's only been about 50,000 years since the one hit
Since
Arizona.
that poor guy, that poor guy got nailed.
But that's not quite how statistics work. But we're going to take a very short break right here, and we're doing pretty good on time overall. This video is about 7 minutes long. It lets folks in our audience here stand up, stretch, if you need to use the restroom or something. Folks at home, enjoy the video. It's a little dark again. What you're going to be seeing is impacts hitting Earth of increasing size. And, well, at the end, they hit us with something really big. So it's probably not going to happen. These aren't predictions. This is just for fun.
Yeah.
So
a lot
anyway,
of fun.
we're going to take a little break. We'll be back in about 7 minutes and change or so. So enjoy the video. assume my mic is back on here. Welcome to the second half, although it's kind of the third of All Space Considered tonight. Yeah, don't let that depress you too much. You saw the how infrequent those really big impacts are. They don't happen very often. If they do, it would be a really bad day for all of us, but that's why we go and find these. That's why we have programs to find the near-Earth asteroids, find the ones that are potentially hazardous asteroids, and it's why we make plans to do something. Now, if Ceres were coming at us, there's nothing we could do. Forget about it. But something of moderate size, something that if it hit a city, it would destroy the city. We're starting to make plans for how to move those out of the way. And you'll hear about that later when Jared talks. But first, let's hear from Katie Flynn tonight. Let's hear from Katie. Yay! Hey. And let's look at some beautiful pictures and think about some nice things for a little bit before we...
Shall we dim the lights?
Yeah, let's mellow. Yeah. There we go. Thank you.
Dinner.
Oh,
wow. There we go.
So this first beautiful image was sent to me by our very own museum guide, David Pinsky, today. And
ooh, nice.
who's standing right up there. And I can't really see my notes. This is crossed polarized, thinly sliced, stony meteorite. And this is through your stereo microscope. And here we have the conjunction of Venus and Jupiter.
Yep.
And this is from Dr. Sebastian Voltmer. This is from March 1st.
Wow.
And this is star trail above Mount Zocolaro. That's in Italy. This is Dario Gianoble, who said this was the most incredible eruption he'd ever witnessed. And then this is from Damien Peach. This is actually from 2022 in September. And you can see Jupiter, of course, in the great red spot, and that little dot in the center is the shadow of Io, and you can actually see Io there as well.
Yeah, I see it.
Yeah.
Wow.
And then this stunning image
Where
was
is that?
sent to us by Jerry Rees, and this was March 7th, the full moon set behind Griffith Observatory.
Yeah, that's Photoshop.
Yeah. Well, the moon just barely fits on the front lawn. It's incredible.
Now,
It's the next impact video.
Well, what's
Oh, no.
You know,
This is the pretty picture segment, Jerry.
And out of all seriousness, to get a shot like this, you have to plan it, know where you're going to be. 'Cause,
Oh, yeah.
you can change the relative sizes of something in the foreground and the background by being at a different distance and using a different zoom. So you can do tricks to make a bridge look as huge compared to something else. But this is a really great photo.
Oh, yeah. I mean, if it started rising in the wrong place and you'd made a mistake, you can't just, whiz down the road. That's impressive.
This is planned out and super
yeah.
great. So
And
impressive.
PowerPoint suggested that this was a hot air balloon, which I thought was pretty funny.
Yeah, very, very big one.
And this is a sun halo from Griffith Observatory. This was actually taken by another employee here, Alan Alt, who's right up there.
Yay,
Right on. Yay.
Not too long ago.
a
And a
great
sun
photo.
halo, occurs when light passes through the ice crystals of high altitude clouds.
Now, what's
And yeah, go ahead.
Well, I was just going to say what's crazy in this one. You look on the left. There's what looks like what's called a sundog. There's a bright sort of rainbow feature, but it's not in the right spot, and we're not sure why it's there. The ice crystals were doing something funky. Alan cast a spell on it or something. I don't know what, but it's a great photo. It's very interesting.
Yes, thank you so much for those, Alan. And then on to some solar system weather. February's been a very strong month for solar cycle 25. You can see July 2025 is the peak there, and we are at the yellow arrow. So the gray line is the uncertainty in the forecast, the red is the official forecast, and the black line is the actual data. So we are above that. And the average sunspot number was among the highest in 10 years. And this one I had to add, this is actually from January, but this is our sun, and that black dot you see is Mercury moving past there. And here is another incredible video of that. And the Bepi Colombo mission will do a flyby of Mercury in June of this year, and the next solar orbiter pass of the sun will be in April. So this image of our sun is from February 25th, and the sunspots to take a look at specifically are 32, 34 on the top kind of left, and then the 3229, because 3229 caused a chain reaction. And this photo is from Eduardo Scharberger, hopefully I pronounced your name correctly, on the morning of the 25th. And this photo is just absolutely incredible, so thank you for allowing us to show it. So right where that sunspot was in the top right corner, that produced a solar flare. And there was a chain reaction that caused some coronal mass ejections as well as a radial blackout over the Pacific Ocean. So here are the 24th to the 25th on the left there, that coronal mass ejection, and then the right, I believe, was from that AR 3229. Wow. So just about the same day. And this image is another one from Eduardo, which is very incredible. This is called Plasma Falls on Space Weather. And they say imagine a waterfall of hot plasma falling, which is tall enough to swallow 10 Earths. And Eduardo said that this was 100,000 kilometers above the solar surface.
Yeah, 10 Earths, that's like Jupiter-sized.
Yeah.
That's huge.
So
it's
beautiful.
Crazy.
And then, of course, I've seen so many aurora pictures lately, and this one is from Dr. Sebastian Voltmer again, and I love this one because it has Cassiopeia on the left there, if you can make that out.
Yeah, one of my favorites.
Yeah, this is from February 23rd. This one I just found. This is Mary Beth Kaczynski, who was on a flight from Seattle to Alaska and was able to capture this image. Very lucky. I would love to see that.
I think that's what always happens on
From
the
a
side of
plane.
the plane I'm not sitting on.
I know.
Right?
Yeah, there was a flight just a couple weeks ago that actually did a full 360 en route.
Oh, really?
So that
They
the
banked it
pilot
so
did a full
everybody-
360 so everyone on the plane could see it. So.
Oh, that's
Great.
amazing.
Except that one person in coach complaining about the fact they'd be 10 minutes late.
Yeah.
Everybody was happy.
Or the person who was in the loo. You know, gets back. Yeah.
Exactly.
Did I miss something?
What happened? But just amazing. You know, open your windows and night flights.
Don't open the windows as such.
No, open the blinds.
Open the blinds.
Oh, yeah, and I will...
Open your windows, take a breath of fresh air.
Pow! Out you go.
I will add that auroras were sighted as low as Illinois and Oregon from those coronal mass ejections from the 25th.
Yeah, my friend in Oregon, if you're watching tonight's Zoom, I did get a message that said, it's completely overcast here. We're not seeing any aurora where he was outside of Portland. So.
Well, and then we have the sky report. Patrick is not here with us, but this is a graph that Patrick usually shows and is in his sky report for March 1st. And the vernal equinox is on March 20th, which is this upcoming Monday. And this is actually a great time to observe aurora. This is called the Russell-McFerrin effect. I had to get that right. And during equinoxes, the orientation of Earth's poles are perpendicular to that of the sun. So, so that maximizes the coupling between the solar wind and Earth's magnetic field.
Don't worry, be happy. I think it's a different
coupling.
I am a lot happier than when all the asteroids were destroying cities on Earth. So yes, this is nice.
And another image from Patrick, just showing the vernal equinox. And we have the new moon coming up right after the equinox, so it's a perfect time to stargaze after you watch the first sunset of spring. And here is March 23rd, 7:45 in the evening sky. After sunset, you can see Jupiter, Venus, and a tiny sliver of a crescent moon right in between the two planets, which would be a lovely sight. On the 28th, we hit first quarter moon, and this next sky chart will show how the moon will appear each night at 7:50 p.m. As it makes its way toward first quarter, it will be right next to planet Mars. So lots to see in the evening sky. March 31st, if you're an early riser, this is 6 a.m. You can view Saturn in the pre-dawn sky. On April 4th, the day before the full moon, you can see Mars, Venus, Mercury, and the moon all the way across the sky. Same with April 5th, and this is actually the moonrise in the east. And our morning sky, 5:45 a.m., we can observe the moon closer and closer to planet Saturn every morning. So if you're an early riser, this would be something very beautiful to observe. It'll just be a tiny sliver as it passes Saturn. And now on to the drought report. This incredible image was taken by Anthony Perkic, who's a telescope demonstrator here from Lake Matthews. Yeah.
It looks like Oz.
Yeah, it does.
Exactly.
Make you fall asleep. And then David Pinsky, of course.
Yeah, David.
By the way, David Pinsky's up there in the back.
Yeah.
Take a bow,
Yes,
David.
thank
Bravo.
you so
Good
much,
job,
Pinsky.
Well done.
Great stuff.
And Pinsky takes incredible images of Mount Baldy with the city, and I love I think this is Kenneth Hahn State Park that you take these photos. Yeah, so beautiful angle.
It's by the Martin Luther King Monument. It's the absolute perfect place.
Yeah.
Anywhere in the
If
city.
folks on the stream, by the way, they can't hear you, Pinsky. So he says that if it's near a monument.
The
That's
Martin Luther
the
King
Martin Luther
monument?
King monument in.
At the park.
Yeah,
It's
so.
great place to photograph it.
Wow.
Yeah, thank
excellent.
you.
Beautiful.
And this
Thank
was
you.
after one of our big rainstorms. So we'll take a look at the current drought report. This was released today. This is from Tuesday. So the no color is no drought. The yellow is abnormally dry, moderate to severe extreme. And so we'll go back to 2020 to take a look at our progress. So this is March 24th, 2020. And then we'll hop to 2021 in March.
Ouch.
And 2022. And then, of course, back to right now, which is a lot better, luckily.
Now, all the
job,
cheering
Alex.
aside, no, you can go forward one
yeah,
if you want.
go ahead.
All the cheering aside, this is great news, but we need to refill our aquifers. And
Yeah.
1 year won't fill the aquifers. I was listening to some scientists, and they were very worried about it, saying reservoirs will fill, this is great, but we're going to need several years like this to start to replenish them. We've been draining them, so it's something to worry about.
Yeah, and if you look at, the yellow is still abnormally dry, moderate, and severe. So, and then this is from the Los Angeles Almanac of the rainfall for downtown Los Angeles. You can see on the left, that is our current season in inches. The middle is the normal cumulative, and last season, 2021 to 2022, is a lot lower. So we've gotten a lot more rain this season than what's normal and from last season. And then just to close the drought report with another beautiful image of poppies, and this one's from Anthony Perkic as well.
Beautiful.
Poppies.
So
Yeah,
maybe you can get out to go see those.
Just amazing pictures. Yeah, it's going to be a super bloom this year, I think.
Yeah.
With all this rain.
Fantastic.
We ought to be able to see that. And Patrick will hopefully be able to get a bunch of pictures out there. He
lives out in the high desert.
Yeah, he does. He lives out near the Poppy Preserve that's out there. So maybe we'll take an all space considered trip out there and go take a look. Well, now we're going to turn our attention a little bit back to our comets, asteroids, and meteors and talk about an asteroid. And the question I posed is, we know a lot about asteroids. We know they hit us, but have we ever gone and visited them? And Haley, one of our museum guides here, and also an All Space Considered correspondent now, has been joining us. You've seen her on our remote broadcasts. Like I mentioned, was exposed to somebody that wasn't feeling so well. And out of an abundance of caution, she's feeling fine, but thought, let's not take any risks. So she decided to record this for us tonight, much like Sarah did. Yeah.
Not only have we visited asteroids in our solar system, but we also recently just brought back samples from one of them. In 2014, the Japanese space agency JAXA launched a mission called Hayabusa 2 to an asteroid called Ryugu. Ryugu is of special interest for a lot of reasons. It's pretty small, only about 900 meters in diameter. It also orbits really close to Earth, sometimes coming only within 95,000 kilometers of our own orbit. So this means it was potentially easy to reach. From a scientific standpoint, Ryugu poses some interesting questions and opportunities about early solar system formation. Based on the appearance of Ryugu, hypotheses about its formation were made. It's a relatively rubble-covered asteroid with lots of boulders very visible on the surface, which means that it is most likely the result of a reaccretion of material from a previous planetary body. The figure here shows a hypothetical formation history for Ryugu, which means that the information stored in the rocks of Ryugu might have clues to earlier periods of solar system history. So the Hayabusa 2 mission from JAXA was created to visit Ryugu, spend a year and a half surveying the surface by landing on it, collect some samples, and ultimately bring some of them back by 2020. So here is a little image of the shadow of Hayabusa right above the Ryugu image, or Ryugu surface. And this is an image showing the mission step by step from launch to arrival on Ryugu in terms of orbital proximity. And this is a GIF showing what the very, very first moments were like landing on Ryugu's surface. So after the samples of rock grains were retrieved, they were returned to Earth in this little vacuum-sealed capsule via parachute, where they were very carefully collected. So in the upper left-hand corner, we have an individual in a complete hazmat suit collecting the capsule. So very careful not to contaminate any of the samples, since that would directly contradict the purpose of the mission. You can see the outside of the sample capsule on the upper right-hand corner, what it looked like when it was attached to the parachute right after landing. And then finally, in the lower right-hand corner, we have an image of inside the capsule itself. So sort of a little carousel of all the samples that were collected. But throughout this entire show so far, we've been talking about space rocks falling to Earth. So I want to step back and maybe give some context about Ryugu fits into our larger narrative and why it's so important. So if we have all these space rocks falling to Earth every second of every day, why do we need to go send a whole spacecraft to the asteroid belt and bring stuff back? Why can't we just use stuff here on Earth if it's everywhere? And so part of the issue is because the stuff that falls here to Earth is not really a true representative of what's in space. So when a rock falls to Earth from space, it has to pass through the atmosphere, which is no small feat. This causes the rock to heat up, break apart, melt, vaporize, etc., making it quite difficult for it to actually even reach the surface. And if it does hit Earth, it's exposed to copious amounts of surface weathering. So this meteorite in this image has a nice crust, a nice rusty crust of oxidized material from being exposed to all the oxygen at Earth's surface. This weathering process makes it hard for scientists to accurately understand and measure the origin material of the meteorite, so its asteroidal parent body. So that's why it was so important to do a sample return mission. These would be grains of rock collected from the surface of whatever parent body the mission is going to. In our case, it's Ryugu. Seal those samples into a vacuum capsule to prevent any interaction with Earth's atmosphere or any sort of alteration that could occur once collection happens in between that time and when it's returned to Earth. And so this would allow us to preserve the exact conditions, or as close to as possible, of the asteroid itself. And so I'm sharing with you a new study that came out earlier this year called Early Fluid Activity on Ryugu Inferred by Isotopic Analyses of Carbonates and Magnetite. So this was published in Nature Astronomy, so kind of high-profile news, and it was outputted by one of the Hayabusa teams that received the sample return contents. And so this particular study illustrates very nicely why it is so important to actually get these samples back to Earth in pristine original material. So this study took a look at several grains from the return mission to look at minerals that are known to form in the presence of water. And so this particular team, the Phase 2 Curation Kochi team, with the paper co-written by two early career scientists, Drs. Caitlin McCain and Nozomi Matsuda, specifically analyzed these grains of carbonate minerals for their carbon and oxygen isotopes. So again, carbonate minerals are formed in the presence of fluids like water, and the proportions of the isotopes of oxygen and carbon within the minerals can tell scientists about the history of the fluid interacting with the rock during accretion and formation of the material. And we can also get a look at the type of associated chemical alteration processes that were occurring. And so for this story, I did sit down with both Dr. McCain and Dr. Matsuda to learn about the process of making these measurements and to hear more about what they found. So this is an image from their paper. It's a scanning electron microscope image of a grain from Ryugu, which allows really in-depth imaging of the crystal grains themselves. So the annotations on the figures are pointing out the different minerals that they measured from. So MGT is magnesite and Dol is dolomite. These are the minerals that McCain and Matsuda wanted to measure the carbon and oxygen isotopes from. And so what you'll notice is the scale bar in the lower left-hand corner. It says 10 microns. Microns is a very, very small amount of space that we're working with, so very small part of the grain itself. And in order to make measurements of the isotopes, you have to make an even smaller measurement on these grains that is only a couple microns in diameter. And so this is a processed figure sort of illustrating what McCain and Matsuda had to do. So they used a fancy instrument called a secondary ion mass spectrometer. This is a very precise and sensitive machine that is perfect for analyzing very small regions of samples. It's even more perfect for a very delicate, important sample, such as the Ryugu return samples, since it would be really awful and inconvenient to have to destroy the whole thing for one measurement. And so the way this machine works is by shooting a stream of charged particles called ions at a spot on the sample surface, again, no larger than a few microns. And this ion stream causes successive layers of sample material to be sputtered off, which releases them as also charged particles, which we call secondary ions because they are the second particle that is being ionized. And these secondary ions are then collected by a detector and analyzed. And in this case, the researchers collected the oxygen and carbon that was sputtered off and then subsequently measured the isotopes of each element. And so by analyses of these carbon and oxygen isotopes, the researchers were able to find that the fluid active on these rocks was between 0 and 20 degrees Celsius, which is between freezing and just under room temperature on the Fahrenheit scale. So it's actually pretty warm by human standards, and it's also pretty warm by space standards. But McCain and Matsuda also measured abundances of isotopes of manganese and chromium in the carbonate minerals of Ryugu. So measuring these isotopes also helps them determine the timing of liquid water presence and of formation of the rocks that eventually came together to accrete Ryugu. So using a new methodology that more tightly constrains analysis results, McCain and Matsuda found that the formation age of the rocks and their associated fluids were within the first 1.8 million years of solar system formation history. This is a vastly older age than other similar studies on carbonaceous chondrites, which are a family of meteorites that commonly fall to Earth and have provided essentially some of the most accurate underpinnings of solar system formation history. And so when carbonate minerals are measured from these meteorites, the formation ages come out to be about 4 to 6 million years after solar system formation. And by extension, those ages are then applied to models that indicate larger parent bodies of those meteorites may have started to see carbonate formation as early as 3 million years after solar system formation. So this 1.8 million years after solar system formation result that McCain and Matsuda and their team got is quite pivotal. It is quite younger. And so additionally, after incorporating their isotopic results into a model, accounting for the accretionary dynamics and parent body size of the likely progenitor to Ryugu, McCain and Matsuda were able to posit two hypotheses which are consistent with contemporaneous planetary modeling studies. And these are that the original protoplanetary body of Ryugu was probably about 20 kilometers in diameter, or it was a larger body that was disassembled before reaccreting. So what does this mean in the grand scope of modern day planetary science? So this paper was a very detailed look into the very earliest years of planetesimal and protoplanetary formation in the solar system. This study shows the evolution of early fluids and their alteration of the first rocks, and even dates the process. Dozens of other studies from Hayabusa teams have shown that Ryugu samples contain interesting compounds like carbon-based molecules. Being able to constrain the chemical composition and alteration byproducts of fluid from early in the days of solar system formation allows scientists to start hypothesizing what environments might have been like on these small bodies that gave rise to these carbon-based molecules, and if any of these places might have life themselves. So you can look forward to more interesting studies trying to characterize the grains of Ryugu in an effort to better understand what conditions were like in the early solar system, both from a pure science standpoint and also as an application to the search for life elsewhere.
So, complicated stuff there from Haley, but wonderful job on that. But I want to summarize it just a little bit for some of you that might have gotten lost in the details there. What's important about this is they discovered that the rocks on Ryugu, that rubble pile, had been altered by water. That little thing, 900 meters across, it obviously didn't have flowing water on it. There's no way. It's also a big rubble pile. So this supports the idea that you had to have a bigger object to have water flowing on it, something at least 20 kilometers in size that would have been hot in the past, could have held onto it, maybe could have had some pools of water when it was hot, altering these minerals. Then that thing got destroyed, and then Ryugu reaccreted, reformed from that destroyed object. So the fact we're able to piece that together, and the fact it happened so early in the solar system, is fascinating. So very, very interesting stuff. But for those of you that got a little lost by that, that's why that's so important. So interesting stuff. And also keep in mind that these smaller objects are the sorts of things that came together to form our own Earth. So by studying these smaller objects, we're learning about the formation of all the planets in our solar system. So, well, folks, we finally have gotten to the time to allow Jared to talk. So, as always, those of you on the stream that have been typing into the chat, where's Jared? We put him on stage so you could see him this whole time. But it is time for Out to Launch.
Yeah, and we're going to actually start off not talking about a launch, but we are going to talk a little bit about an impact, but a good impact.
Okay.
So not a bad one. So I know we've been doom and gloom, but I do want to talk a little bit about DART, the Double Asteroid Redirection Test. The first big results of this mission are finally coming out. You may have seen it back in September when it smacked into one of the moon Dimorphos, which is actually a smaller moon of a larger asteroid called Didymos. I wish they had kept the original name for Dimorphos, which was Diddy Moon. So, but unfortunately they didn't. But DART came in the opposite direction that Dimorphos was traveling and ended up smacking into Dimorphos at somewhere around 6.5 kilometers per second. So imparting a tremendous amount of energy, somewhere they think about 3 tons worth of TNT in energy coming off of it, and excavating anywhere from 1,000 to 10,000 tons of material off of Dimorphos. We also had a second spacecraft called Lixia Cube, which took images that I'll show you in just a little bit after that. But I do want to show you, DART had a camera on board that it was essentially a navigation camera that allowed it to get in there as it went past Didymos, lock in on Dimorphos, which is about twice the size of the observatory, and then smack it right exactly where it needed to do so. And what was really cool is that we got to watch this live as it was happening, as they were transmitting this back. But here it comes. It's getting locked in. At one point, it's going to stop because it's good to go. And then, boom, coming in real time here. And it hits right between those boulders. And it smacked right in the middle of broadcasting that image to us. But that's okay.
Who knew asteroids had red blood?
Yeah, turns out. So
I don't know, this is very satisfying after all the stuff those asteroids did to us in the first part of the show.
I was going to say,
our revenge.
I was kind of joking about the fact that this is our revenge for the dinosaurs. We're avenging them.
They had it coming.
With that there. And that's the start. So this was actually an image taken about a week after the impact. And you could see that we've got a very long tail of material coming off of this, hundreds of thousands of kilometers long. We're talking longer than the distance from the Earth to the Moon in this case. So a tremendous amount of material as they were expecting. I think it was somewhere on the order, about an order of magnitude more material excavated than they were originally thinking was going to happen. And they think that the amount of energy that DART imparted into Dimorphos was actually about 2 to 5 times more than they expected to. And this is also another great view here taken from the Southern Observatory. As you can see, that is the plume coming off of Dimorphos there right after impact. They did a great diagnosis, a great post-mortem of how DART impacted into Dimorphos there. I love the chalk outline of DART right there. It's pretty great. And then seeing that it actually hit sort of a little askew, so not quite vertical, not quite perpendicular with it there. And also we saw where the solar panels were lined up as well during that impact, which they put them in what they thought would have been an area that would have imparted a maximum amount of energy in, which it didn't. Eventually, we took radar imagery from the Goldstone Deep Space Communication Complex here in Southern California. We looked at Dimorphos, which you can see. It was really easy to find it. There's a green circle around it now ever since we hit it with DART. But
it's very helpful.
Yeah,
really.
Quite. That's how we were able to aim it so good. And we actually were originally wanting to get at least 70 seconds. We wanted to slow down its orbit around Didymos there by 70 seconds, and we ended up doing it by 32 minutes, which was 3 times what they thought we would maximum be able to put out of that there. We thought we could get maybe 10 minutes out of slowing down its orbit. We got 32 minutes out of it there. So that essentially tells us that this kinetic impact, this ability to basically run a spacecraft into an asteroid is capable of, as long as we have enough time, is capable of actually saving the Earth. And in this case, with something the size of Didymos, they would have been able to move it the diameter of the Earth over the course of about 20 years. So if we had 30 years of extra time, 10 years to get the mission together, hit it, 20 years, it would have completely missed the Earth by 1 Earth diameter, roughly. And I mean, you don't really need 20 years. You could do 10 years. You could even do 5 years in that case.
Or hit it with something bigger.
So yeah, or
just
hit it harder.
Or multiple.
Yeah, get it with that there. And then, of course, I mentioned about Litia Cube, which was a small CubeSat that was deployed just before, a couple days before impact. And it actually took multiple images that they put together of the impact as it flew past just a couple thousand kilometers away from that impact there. So absolutely astounding results from DART. And we also got, of course, a really great up-close look at Dimorphos, which is a rubble pile here.
Go back one.
Sure.
Notice those streamers you're seeing there come off of it? These, well, they were a little bit of a surprise, but it's the same mechanism that creates the rays on lunar craters, we believe. We think that this is probably areas where there was something blocking the material a little bit that allowed some to get free, and once some gets free, more can head that direction. But it's not super well understood. But you look at craters on the moon, and rays come off of it in sort of these long streamers. Very reminiscent of what we're seeing right here.
Good example of science teaching you something in a totally different area you didn't expect.
Yeah, and actually that very fine material coming off of it kept coming off of it for days after the impact. And they actually think that that's where a majority of the energy imparted that moved Dimorphos there actually came from. That it wasn't the hard impact itself, it wasn't moving things like boulders, it was actually getting that very fine material, the very fine ejecta coming off of it over days coming off of it that actually is what caused it to get most of its energy in what moved it. So absolutely, just an astounding mission. We are going to go back to that system with a spacecraft called Hera from the European Space Agency. It'll also have 2 CubeSats with it as well. They're going to go look at Dimorphos very up close and see what it looks like. So very excited to see that. It'll be launching in 2024, and it will be arriving at the Didymos system in 2028. So I'm very excited to have that, and hopefully this one will not hit it. That's the goal, get in orbit around it. Of course, I'm going to give you a little update about Lucy, one of our spacecraft that we currently have heading out to the Trojan asteroids. This one had a little bit of a problem because one of its solar panels didn't deploy entirely completely, but they were able to determine that even with that solar panel partially deployed, it's still going to be able to do its mission. They went ahead and tried to do some work on the solar panels, troubleshooting a spacecraft from tens of millions of miles away, and they were able to get it to open just a little more, but then they were like, you know what, let's not push our luck any further because it's working anyhow. It's actually going to do its first flyby on November 1st of this very small asteroid on its way out. It'll come within a couple hundred kilometers. So great name there, 1999 VD57. And this is one that was just found on the way while looking at a whole bunch of objects with trajectories that Lucy didn't need to do much of a burn for to get to. And I always like showing off the actual trajectory that Lucy is going to be taking here. Because this is some amazing stuff that the folks at NASA have been able to develop with this here. So Lucy's going to the Trojan asteroids, which are out in the Lagrange points, these gravitational balance points between Jupiter and the Sun. So it's not just Earth and for your colonies in Gundam, it's also other planets as well have these places where you can basically drop these objects and they'll stay there. And Lucy will go visit several in the first area there, and then visit some more in the second set of Trojans that you have right there. So just an amazing trajectory that they were able to develop with it here.
Well,
so.
I like that it comes back and visits Earth again.
Yes.
Hi, everybody.
Yeah, we got to fling it once more, you know, with that there. And then we also have a asteroid called Psyche, which is going to be visited. I'm very excited about that.
Psyched for it.
What's up?
I'm psyched for it.
Oh, yeah, definitely psyched
I have been all along.
For it.
This is great.
We like Psyche because it's a metallic asteroid. We think it is mostly metal, but the thing is it's somewhere on the order of about 250 kilometers in size. So this is definitely the largest metallic asteroid that we're going to go visit. We don't know how heavy metal it is. I'm hoping it's going to be extra metal once we get out there, but we'll have to see. Psyche currently in the development stages. They had to delay its launch a year to later this year because of some software issues, but they are going to go ahead and move forward with it. It'll be doing 4 different series of orbits as it goes around it, for studying it for about a year. And then, of course, we always like to see photos of hardware, so there it is, getting itself ready to go, testing out those solar panels. You can see very big solar panels to power it as it goes far away from the sun. So that's sort of a little good end for our impact stuff today. And now it's time to get into the rockets, which is what I like.
All right.
The good stuff. So if we got it, so we could talk about the Starship Super Heavy finally coming to life, lighting up those engines in a static fire test. Take a gander here. So the sound of 31 Raptor engines momentarily coming to life. There were 33 on Starship, 1 shut down. One shut down just before ignition, and then one as it spun up to its proper throttle setting shut down as well, so they had to drop 2 of them, but it still was a successful static fire. Very much looking forward to this absolutely massive vehicle. Just to let you know, the entire stack of the space shuttle, so space shuttle solid rocket boosters and external tank, is about 40 feet shorter than that single super heavy stage right there. So that's bigger than the entire space shuttle stack. They'll be putting out about twice the power of a Saturn V on liftoff. That should be coming sometime in the next
If they
month.
lost 2 engines like that when they were really trying to launch it, would they go ahead with the launch? Does it have the ability to do that?
Yeah, so it does have engine out, what we call engine out capability. So this is basically because it has multiple engines, it can lose engines on the way to its orbital flight test, although not really orbital flight test with that there. And it can lose them, and it'll basically burn its engines for longer in order to make up for losing those engines. That's one of the things with SpaceX's Falcon 9 that they have as well. They have engine out capability on their first stage with that. So that was their Starship working with that there. And then, of course, we had Crew 6 just launched to the International Space Station last week. So really great to see them heading on their way. And, of course, wearing those very cool intra-vehicle suits that SpaceX has the astronauts use on their way when flying in a SpaceX Crew Dragon on its way up. So that was,
Tesla.
quite entertaining. Yeah, of course. I
Yes.
wonder why they're using Teslas to take them out to the launch pad there. But very interesting thing I always feel like doesn't get pointed out is that they actually don't do what NASA did back in the day with things like the Saturn V and the shuttle, where they would fuel up the rocket and then have the crew go out to it. With SpaceX, they actually do what they call load and go. So they put the astronauts on board of the spacecraft, and then they load up the Falcon 9 rocket with all of the propellants that they're going to be using to fly it into space. Of course, we have the now standard SpaceX Ninjas getting everybody in and set with that there, and then the liftoff of that Falcon 9 heading on up with the crew to the International Space Station. So beautiful night launch, but unfortunately, because it was a night launch, not much to see in terms of the tracking cameras, but still great to have them on the way. And then we had the exact opposite. Crew 5 came home just a few days after that, getting Crew 6 up to speed. 4 astronauts returning from the International Space Station, including Nicole Mann, who was the first woman to command a commercial crew vehicle, and also the first woman of indigenous heritage as well to command a vehicle. So very, very cool to have that happen. Then we had Japan's H3 rocket.
It's a good-looking rocket.
It is a good
Beautiful rocket. The Tanegashima Launch Center in Japan is beautiful as well. Take a look at this when it goes to the wide shot. Just picturesque. But this rocket, a collaboration between JAXA and Mitsubishi Heavy Industries, unfortunately it did not have a success on its first flight. And in fact, we're going to zoom in here and I'll slow it down for a little bit. Now that we've seen the SRBs separate, we're going to look at the view here. You're going to see the sort of cylinder of the rocket begin to yaw a little too hard. And now it's going completely sideways, and that's really bad. I don't know if you guys know much about rockets, but going sideways in a rocket, very bad, especially that far along in the launch. So unfortunately, they did have to activate the range systems and destroy the rocket. But they'll get back on it. JAXA is very, very good at figuring out what is going wrong, and they're going to work on that. Then we had another one, Relativity Space, local company here, getting ready with their Terran 1.
Is this the 3D printed rocket?
Yeah, this is the 3D printed rocket.
That looks cool.
And that's a shutdown. So I know most people would look at a rocket aborting its launch as a bad thing, but
No,
if you
the rocket's still there.
the rocket, yes, as you're pointing out, myself and Chris having aerospace background, we understand that if your rocket and your payload is still there, your customer is happy, and you could fly another day. So that was the whole point, and that's a very good thing to see a relatively new company, having that happen with their rocket. So about a week from now, March 23rd, as of this show, is when they're going to be attempting again. But 85% of that rocket is 3D printed, which is the largest amount of additive manufacturing for any vehicle. So absolutely amazing. They think within about 2 to 3 years they might be able to get the entire rocket 3D printed.
So I have to go and cut all those little vertical spines off of it when... Anyway,
Yes, exactly. So like paper fold.
Anyway, that's a 3D printer. A little joke for you.
And unfortunately, you may have heard our Soyuz problems that have been occurring with our Russian friends over at Roscosmos. They've been having problems. Soyuz MS-22 sprung a leak in December, and then their Progress resupply vehicle that's uncrewed also sprung a leak, and then they launched Soyuz MS-23, which was the rescue vehicle for the crew of Soyuz MS-22, and they now think it has the exact same flaw that MS-22 has. So they're going to have to return it even sooner. So those astronauts are going to have to speed up to get back home, assuming it doesn't spring a leak by then.
Those Russians are going to be longing for a ride in Tesla.
Yeah, I was going to say, actually on Crew 5, one of the astronauts was a Russian, and she had very high praise for the flight with it there. Now, of course, just want to let you know your Vandenberg Space Force base schedule coming up. All launches with an orbital velocity through the next month. You're going to have one actually tomorrow. You got to get yourself going. You got 16 hours to get up there.
And rain.
At 12:15, yeah, and some weather potentially for a Starlink launch, which I know, talking about Starlink here at the observatory, I get the applause and happiness of everybody around me. Then we've also got a SDA Tranche 0, which is a communication system that they're going to be testing for the United States Air Force. And then another Starlink flight. And then on April 2nd, a Transporter, a small sat launch. Just to let you know, SDA Tranche 0 and Transporter 7 are scheduled to have their first stages come back and land at Landing Zone 4, LZ4 at Vandenberg. So if you've ever wanted to watch a rocket go up and then 8 minutes later have the rocket come back down right in front of you in the same spot, there you go. Stay tuned. Hopefully we'll be having some good stuff come from that.
Awesome stuff. Well, thank you, Jared, for that. That's our Alpha launch. And that brings us nearly to the end of our program tonight. We only went over by about 15 minutes, which isn't too bad considering it's the first time in 3 years being live in here. So thank you, all of those in the audience that stuck with us here. A few folks snuck out early, probably to go catch a planetarium show or look through a telescope, which all of you can do. If you're here at Griffith Observatory, you can go take a look through our telescopes. They're free, open to the public every night that we're open, and the skies are clear. Also, the building is open and free to the public as well. Griffith Observatory is brought to you, as is All Space Considered, by the Department of Recreation and Parks, the City of Los Angeles as well. And we like to thank Griffith Observatory Foundation, which, speaking of which, we have a special lecture coming up. And if you're a foundation member, let us know. You'll be getting information about this. But we have Richard Ellis, Dr. Richard Ellis, who's a good friend of ours. He, I believe, has won the gold medal of the Royal Astronomical Society, believe it or not. I saw his name on that list. Very well respected. He's going to come talk about the first results from the James Webb Space Telescope. And he also will have his book, When Galaxies Were Born. So the very first galaxies there. The book, our gift shop will have copies of that. He'll be happy to sign copies for you as well. That is on April 7th. That is a Friday lecture. So we'll also be streaming it, but come on back in a couple weeks from tomorrow, and we'll talk with Richard Ellis. It'll be a great lecture. So that's our show for tonight, folks. Thank you so much for joining us. It was great to be back in the theater. Thank you. Thank you to all my colleagues on the stage here tonight. I want to thank all of our techs and everybody there. And as our audience makes their way out, up at the top, David Pinsky up there, believe it or not, he has a piece of the Chelyabinsk impactor, the thing that came in over Russia and exploded. He has a chunk of it that was found. You can see a piece of it. And also some glass that shattered that came from Russia. So up there at the top, David Pinsky will show you that on the way out if you like to. And that's going to end our show. So thank you, everybody. We appreciate all of you out there. And we'll see you the next third Thursday in April. Well, maybe April 7th, but then for All Space Considered, we'll be back on April 20th. And next month's show is going to be an Earth-centered show for Earth Month. So we'll do some stories on the Earth. Thank you, everybody.
Take care. Bye.